Welcome back. So now we are looking at the polar form of complex numbers. So there's several conversion formulas. These should look ridiculously familiar because they're just the same things we've been using for rectangular to polar. The only one they didn't write down was the tangent one. Now, what's interesting here is right here. So they factor out the r, and they have cosine theta plus I sine theta. All right? So this is literally just changing out basically y's for i's, like imaginary numbers. Yeah. So this notation here gets abbreviated down to this, r cis theta. So theta is the argument. Cis means cosine theta plus I sine theta. But it's always the same thetas. So they just shortened it to this weird cis notation. And then the r in front is what they call the modulus, which is like the fancy word for radius or distance. All right. So now we're going to practice just going from a normal complex number to polar notation. All right. So the complex number 4i, that is 0 plus 4i. So if I plot that, it's 4 up on the y-axis. So the radius is 4. And the theta is pi over 2. So writing it in polar notation, we would say z equals 4 cosine pi over 2 plus I sine pi over 2. And this can seem a little silly because what we had before was way simpler to look at. What we're going to see later on is the products and quotients and powers and roots of these behave really nicely. All right, so here we have 3i, but we're going to write it in the r cis theta notation. This is rather silly to do right after 4i. So r is 3, and theta is still pi over 2. But now we would say z equals 3 cis pi over 2. All right, down here, finding the polar form of a complex number. So now we've actually got a whole bunch of stuff going on. But I do want to start by figuring out what quadrant it's in. Because remember, finding theta with polar coordinates requires more finicky stuff. All right, so 3, and then -3 square roots of 3. So it's somewhere down here. All right, so quadrant 4. This means if I do inverse tangent, remember inverse tangent is defined in quadrants 1 and 4. So the theta I would get from inverse tangent will work. All right, so we've got 3 here and -3 square root 3 here. There. All right, so if this is our theta, the Tangent of theta is -3 square root 3 divided by 3. Now, square root 3 actually is our 30, 60, 90 triangle. So it's short side, long side. So this is -60 degrees. Which is -pi/3 radians. So our polar form, well, we need the radius. So r is the square root of 3 squared plus 3 square root 3 squared with a negative. So that is 9 plus 9 times 3. So that will be 9 times 4, which is 36. So our radius is 6. All right, so z is 6 cosine -pi/3 plus I sine -pi/3. So we're going to keep these videos shorter. I'll see you on the next one.